Hello and welcome to Sparcon with Angie. On this channel, we explore different types of building envelope materials with insight into their price, durability, lead times, and just general performance over time. Today, we're going to be talking about the world's most widely used building material, concrete, and learn why it's the most popular choice out there. Concrete is the most widely used building material globally. It is a composite material made from cement, aggregates, and water. Concrete can be poured in place or produced by casting concrete in a reusable mold or form, which is then cured in a controlled environment, transported to the construction site, and maneuvered into place. So, why is concrete the most widely used building material in the world? Concrete is everywhere, and it's used in construction primarily because of its strength, versatility, and also because it's actually relatively inexpensive. It's also used universally because virtually every region in the world has the raw materials necessary to produce it. Additionally, the technology that is associated with its production and use is relatively simple. Concrete is a composite material. The basic ingredients of modern concrete are cement, aggregates such as sand and gravel, and water. Together, these materials provide a hard, rock-like substance that is durable, fire-resistant, and relatively inexpensive. While concrete and cement are sometimes used interchangeably, it is important to remember that concrete is the end product, and cement is just one but very important ingredient. Cement is a binding agent and is made of a mixture of limestone and clay. Unlike other structural materials, concrete can be formed to any desired shape. In fact, with concrete, an entire structure, regardless of its shape or size, can be formed monolithically, that is, as if it were one object. The size and weight of the aggregated concrete will dictate the application for the concrete. In concrete, aggregate refers to the granular materials like sand, gravel, or crushed stone that are mixed with cement and water to form the final concrete product. Aggregate in concrete occupies 65 to 80% of the volume of concrete, the remainder being cement and water. The aggregate must consist of different size particles. This is referred to as size gradation. Proper gradation ensures that smaller particles fit within the voids created by larger particles so that the entire mass of concrete is relatively dense. A well-graded aggregate, implying that it consists of particles of various sizes, not only gives a stronger concrete, but also reduces the amount of cement necessary to wrap the particles and fill the spaces between them. An aggregate that consists of particles of only one or two sizes has a higher percentage of voids and therefore requires a much larger amount of cement. Because cement is far more expensive than aggregates, this gives an uneconomical concrete and may not be practical for financial reasons. The quality and the amount of water will also determine the overall strength and applicability of concrete. Cement derives its cementing property from its reaction with water, but the less amount of water used within the formulation, the stronger the concrete. Furthermore, the water used in concrete must be clean. A rule of thumb in the concrete industry is that if the water is fit for drinking, it is also fit for use in concrete. Seawater is not good for concrete structures. That's because seawater contains salts, and when it comes into contact with concrete, it can lead to corrosion of the reinforcing steel. Seawater also modifies the cement-water reaction and is therefore not appropriate for use in concrete. In fact, concrete failure can occur in coastal areas where the concrete structures come into direct contact with seawater, which can, over time, significantly affect the integrity of the concrete. Recall the Surfside building collapse of June 2021 in Florida. A contributing factor under investigation is long-term degradation of reinforced concrete structural support in the basement level parking garage under the pool deck due to seawater penetration and corrosion of the reinforcing steel. Despite being the most widely used building material in the world, many don't know that concrete is one of the worst CO2 contributors in the world. Concrete is the highest consumed product on Earth besides water. As a material that creates the majority of the world's bridges, roads, dams, and buildings, concrete releases an extreme amount of CO2 each year. The key factor contributing to concrete's CO2 footprint is actually in the cement production. The primary ingredient in concrete, cement, is produced by heating limestone and other materials in kilns, releasing CO2 both from the chemical reaction and from the burning of fossil fuels like coal or natural gas. The global impact of cement production is significant. Cement production contributes 7 to 8% of global CO2 emissions, making it a substantial source of greenhouse gas emissions. The presence of some substances in concrete, including some useful and some unwanted additives, can sometimes cause significant health problems due to toxicity and sometimes naturally occurring radioactivity. In another episode, we will explore carbon emissions from concrete further, and we'll also look at some of the mitigation strategies that are out there. Thank you so much for watching, and please join me on the next episode of Sparcon with E&G, the source for building envelope material insight. Thank you for watching, and please join me on the next episode of Sparcon with E&G, the source for building envelope material insight.